Hello. This week we're going to be talking about how to organize data. You might remember that last week we talked about the steps of social science research and we divided them up into 5 steps. So after you had a research question, you would develop your hypothesis. Next, you would decide your method and develop it. Third, you would collect your data. Fourth, you would analyze your data. And then fifth, you would interpret your results and communicate them to an audience. So this class, all semester, we're going to be focusing on step 4, which is analyzing the data. But before you can analyze the data, you need to organize it. So this week, we're going to be talking about organizing data. So I don't want you to be intimidated about this class in general. I want to remind you that you have done this before. Below is a picture of me actually in 4th grade at my science fair. And so you've done these steps. It's just now we're at the collegiate level, so we're just talking about them in a more advanced level. So we're just going through essentially the scientific method step by step. And this class, we're focusing on the details of step 4, which is analyzing data. So before you analyze the data, you have to organize it to make sure that it makes sense. So after you collect your data, using one of the chosen methods, you organize it. Data collection is strenuous and time-consuming, but raw data, just data as is not helpful. So you need to transform it into a meaningful way, and we're going to talk about that and what ways are helpful for being able to analyze information. Organized data allows for statistical analysis. So first, what is raw data? You may have not heard of that before. Raw data are just numbers. So it's just what you get back on an Excel spreadsheet when you're just gathering information. If raw data can also be, with qualitative research, what we talked about last week, that's data that doesn't have to do with numbers. It can maybe be a transcript or something like that. But this class, we're talking about numbers because it is statistics. So you're just getting raw data back. It can be counts, or it can be numbers like this that are interval in nature, or it could be counts in terms of how many counts were in a particular category for categorical data. But it's just raw. And as you look at it, this doesn't make sense. I understand that numbers are there right in front of me, but I don't know how to interpret it. So that's the point of this lecture this week, is being able to describe how to organize it in order for it to be meaningful. So raw data as is, not great. So ways to organize it so it's meaningful, it depends on the type of data that you have. So last week we talked about nominal data, ordinal data, interval, and ratio data, and these are different ways that you can organize these different types of data sets. And as a reminder, this is the difference between nominal, ordinal, interval, and ratio. So if you need to keep this to the side to keep reminding yourself of the differences, please do. So in terms of nominal data, one way that we can organize nominal data is through frequency distributions. And this is used a lot, and it's essentially just the number count of raw cases per nominal category. So think of it as just counted up tally marks. So for example, let's say you're doing a study on children's behavior, and let's say you took away a toy from a child. So what happens once you take away a toy from a child? Well, they could cry, they might express anger, they might withdraw from you, or they just might start playing with another toy. So let's say you did this with lots of different babies, one after the other. You would start making tally marks. All a frequency distribution is the counted up tally marks per that particular experience, crying, expressing anger, withdrawing, or playing with another toy. And then here's how many times that happened. So let's do an activity. What is the N in the previous example? The N, by the way, is the total number of counts, or the total number of tallies. So go ahead and count this up for me and tell me what the N is. The n is 50. So for nominal data, you can also run a frequency distribution, which is comparing different groups. So as you can see, this looks very similar to the last frequency distribution that we saw, except that the gender of the child, male versus female, has been added. So there's additional tally marks here. So now we can see that there were 50 males and 50 females, and these were their reactions after a toy was taken away from them. So just the difference here is that this frequency distribution is comparing different groups, males and females. So now you do one. So here is some raw data. You count up how many times this has happened per male and female. The question here is, do males and females eat ice cream every week? So go ahead and pause this video and take a few minutes to go ahead and fill out this frequency distribution, maybe on a blank sheet of paper in front of you as a scrap sheet. And then once you're ready, press play, and we'll go to the next slide, which has the answer. All right, here's the answer. So go ahead and compare your results. All right, moving on. Something else that you would do in nominal data to be able to organize it, to be able to display it in a meaningful way, is through proportions. So proportions are a way to compare groups with different number of overall cases, or the N. So in the example 2 slides ago, here, there was equal number of males and females. A lot of times that doesn't happen in real life when you're doing real research. So a proportion is helpful. So a proportion compares the number of cases in one category with the overall total. So the equation is proportion equals frequency divided by number. So what is the proportion of girls who found another toy after having had the first one taken away? So let's go back to that slide and look. The question again is, what is the proportion of girls who found another toy after having the first one taken away? So I'm looking at girls, female. I want to see they played with another toy, and it's 15 out of total number of girls is 50. So the equation would be proportion equals 15 out of 50 equals 0.30. So next, your turn. Let's go back to the slide again. What is the proportion of males who cried? Let's go back and look. I'll let you jot down those numbers. Go ahead and put it into the equation. All right, ready? Here we go with the answer. 0.50. All right, so sometimes it's nice to be able to convert proportions to percentages. So to change it from a proportion to a percentage, just multiply it by 100. So the example that we had done together was this one, the proportion of girls who found another toy after the first one being taken away. We found that it was 0.30. To be able to convert that to a percentage, because a lot of times people like to think in 100. It just helps people to make something more meaningful. So we can do 0.30 times 100 equals 30%. Another helpful way to be able to organize data in terms of nominal information are through ratios. So I was smart here. I went ahead and put the little chart up here so we don't have to keep going back and forth with the slides. The ratio, what it does is it compares the number of cases in one category with the number of cases in another category. So the equation for a ratio is the first frequency divided by the second frequency. So let's do it together. So an example would be the ratio of males that express anger we have males expressing anger is 15. And then we're interested in that compared to the number of females that expressed anger, which was just 3 right next to it, 3. So if you say that the ratio is 15 to 3, while that is the ratio, it's not really helpful to think about. People can't process what 15 to 3 means. So you need to make it smaller so it's more understandable for people. So the way that you do it is you divide both sides by their greatest common factor. And so let's go ahead and watch this video on what a greatest common factor is. We learned about it when we were younger, but let's get a reminder.
Greatest or greatest common factor video. So just to be clear, first of all, when someone asks you what's the greatest common divisor of 12 and 8, or they asked you what's the greatest common factor of 12 and 8, that's a C back there for common. I don't know why it came out like that. They're asking you the same thing. I mean, really, a divisor is just a number that can divide into something, and a factor, well, I think that's also a number that can divide into something. So a divisor and a factor are kind of the same thing. So with that out of the way, let's figure out what is the greatest common divisor or the greatest common factor of 12 and 8. Well, what we do is, it's pretty straightforward. First, we just figure out the factors of each of the numbers. So first, let's write all the factors out of the number 12. Well, 1 is a factor. 2 goes into 12, 3 goes into 12, 4 goes into 12, 5 does not go into 12, 6 goes into 12 because 2 times 6, and then 1 goes in, and then 12 goes into 12, of course, 1 times 12. So that's the factors of 12. Let's write the factors of 8. Well, 1 goes into 8, 2 goes into 8, 3 does not go into 8, 4 does go into 8, and then the last factor, pairing up with the 1, is 8. So now we've written all the factors of 12 and 8. So let's figure out what the common factors of 12 and 8 are. Well, they both have the common factor of 1, and that's really not so special. Pretty much every whole number or every integer has the common factor of 1. They both share the common factor 2, and they both share the common factor 4. So we're not just interested in finding a common factor, we're interested in finding the greatest common factor. So all the common factors are 1, 2, and 4, and what's the greatest of them? Well, that's pretty easy, it's 4. So the greatest common factor of 12 and 8 is 4. Let me write that down just for emphasis. Greatest common.
Great. So once we divide both sides, so the greatest common factor in this situation is 3. So once you divide 15 divided by 3 equals 5, and 3 divided by 3 equals 1. So it means 5 to 1. And people can process that better. So it means for every 5 times a male gets mad, 1 female does. So that just makes more sense than when you said for every 15 males that gets mad, 3 females do. And it's the same thing, but again, we're organizing data so that it's meaningful for people so they can make decisions based on it. So you need to be able to report information in a way that people can comprehend. So that's reason why that we need to reduce it down from 15 to 3 down to 5 to 1. So how about you go ahead and do one now? So a frequency chart has not been provided to you, but the numbers from the frequency chart have. So you go ahead and figure it out now. If you need to press pause and go back to the last slide so you can recount how to do it, feel free to do that. And then in a minute, you can press play again and we'll show what the answer is. All right, here's the answer. So the ratio is 150 to 100, but that's not helpful to think about it. So we reduced it down to 3 to 2. So every 3 Latinos, there are 2 white people. All right, moving on. So now let's talk about rates. So rates is the comparison between the number of actual cases and the number of potential cases. So actual is a real number that you have. It's an actual data point, and the potential could be real or not real. So AKA, that's why it's called potential. So let's look at a couple examples. So here's an example with potential as a real number. So let's look at spending in schools. So per pupil expenditure, so the state spends about $14 million on schools. And so you divide it by the number of students. And we know for a fact, so this is a real number in this situation, that we have 2,280 students. So 14 million divided by 2280 is $6,140 per student. Another example, this is an example where we're just kind of guessing what the potential number is. So this might not be a real number, but we think it is. Here we're interested in birth rate. So our actual numbers is that there was actually 500 babies born. We know that. That's an actual number. And then we're dividing it by what we think there are. We think there are 4,000 childbearing mothers in the town. So we divide that, and what we get is 0.125. But again, the point of organizing data is making it meaningful, so that's not really helpful information. So you can multiply it by 1,000 to make it more meaningful. So for every 1,000 women, there are 125 births. Okay, let's talk about, we're going to talk about ordinal data in a second. So I just quickly, before we moved on to ordinal data, I wanted to remind you that it's similar to nominal data, but it's in a particular order. So nominal data is categorical in nature. Ordinal data is as well, but the order, as in the name, matters. So you've seen this before. We've showed this exact same frequency chart earlier in the slide. So all I'm showing you is that the frequency chart for ordinal data is the same. It's the exact same setup, but the order matters. So remember that these are categories, but they're in a particular order. So this might be a survey question, and the answers could be very favorable, slightly unfavorable, very unfavorable. The order of this matters. So when you are putting things on a frequency chart, keep that in mind. Okay, now frequency charts for interval data. So this is a frequency chart of exam grades. So these are all the grades that happened right here. They're also in an order, as you can see. It goes from the lowest to 72 and the highest was 94. And this is how many counts occurred. So 2 people, for instance, scored an 85, 3 people scored an 82. The total number of counts, there's 29 students that took the exam. This isn't extremely helpful because there's so many numbers listed here. So with interval data, it's nice to be able to group it into categories like this. That way you can see it better. And in addition, a lot of times with interval data, you'll also have a percentage offered. So a reminder of how to do that is, here's an example right here. So there were 2 students that scored between 90 and 94. 2 divided by the total is 29 times 100. That was 6.90. That was a rounded up number. So 6.9% of the class scored between 90 and 94. That's an example of that. And the next slide, what we're going to do is we're going to talk about how we decided that we wanted to organize it in this way. And we decided that based on limits. So limits are just numbers before rounding. So where did the students who scored 71.7 get placed? So maybe there was someone who scored 71.7. Well, that got rounded up to 72. Or where did the students who scored 94.3 they got rounded down to 94. So it's just talking a little bit about the limits, and then you can put them into separate areas as you see fit. It's important to know your highest and lowest fit limit when creating a frequency distribution. And basically limits just kind of give you some wiggle room in case there's other numbers that don't exactly fit into the whole number. Okay, another way that you can display your data is through cross tabulations, and this is used all the time in social science research. So it's essentially a table that presents frequencies of one variable, like the dependent variable, across categories of one or more independent variable. So it's more comprehensive than a frequency chart. It always includes the ends, and then it sometimes includes the percentages too. Any type of data can be presented on this, and this is used in social science research to summarize the data almost all the time. You always, when you're using statistical analysis, you're always going to get a cross tabulation. So here's an example of a cross tabulation. This one is pretty basic. It looks a lot like a frequency chart, except that we do have these totals here. So that's a big key difference with cross tabulations, that totals are presented. So an example question is, how often do males and females wear seatbelts? And then here's another cross tabulation that's a little bit more difficult. It includes percentages, for example. So the topic for this study was, what is the relationship between victims and their offenders? And does the type of relationship vary by the victim's gender? So here you can see, let's say the victim was a male. The offender, 4.3% of the time, was an intimate partner. In the case of female, when the victim was female, the offender, 44.2% of the time, was an intimate partner. So it kind of gives more information. It's more detailed than the just frequency charts. Okay, so we've covered tables, so let's move on to picture visuals. Humans like to see visuals. We enjoy them. It helps us to be able to understand what we see. And as statisticians or social science researchers, we want people to be able to use the information that we've found out to be able to make great decisions and improve the world. But if people don't understand what you're trying to tell them or what your results are, then it's not helpful. So it's great to have visuals, and people can be able to really absorb what you're telling them and be able to draw conclusions and use the information that you found to be able to improve whatever it is that you're trying to improve. So graphs are important, good visuals. So a pie chart, this is easiest to understand. The percentage is all up to 100%, and it describes the frequencies or percentages in a nominal level. So here's just an example of, it looks like might be about pizza. Here's an example of a bar graph. A bar graph can accommodate any number of categories at any level of measurement. It's much more commonly used in social research than a pie chart. So this example is, how often do males and females wear seatbelts? And then histogram, this is like a bar chart, but it's used to display interval and ratio data, which is also referred to as continuous data. Like GPA, for example, that might be something that we're interested in looking at. And in this case, it is with this histogram. So you can see the GPA down here, and then the histogram. It looks a lot like the bar chart, except that it's using continuous data, and in addition, the bars are touching. So let's go ahead and watch this video. This is a great video on how to make frequency charts and histograms in Excel. And so let's watch this.
I'm going to show you how to use Excel to produce a frequency distribution and a histogram. We can produce both of them in one shot. Okay, so I have the data here from two population. This column contains quantitative data, and we want to produce a frequency distribution and a histogram for it. So first of all, I'm going to copy it to a new worksheet, so we don't have to be distracted by other things. Then I want to find out what is the highest number and the lowest number in this data, so I can set up my class limit properly. So Excel can do this by using a function called equal max. Open equal max, open parenthesis, you just give the data to it. Excel will look at it and tell you, oh, the maximum is 90. And then equal min, the data value, the lowest is 23. So our logical class limit would be, need to include 23. So the lowest should be around 21, and we wanted to start with a nice number instead of starting from 23. So 21 to 30 seems to be a nice class limit to go with. And then I do 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90. So you have to create this, based on whatever data that you have. Now, but Excel do not look at this. Excel's want a column that contains only the upper class limit. So what you can do is just copy all the upper class limit in a separate column for Excel to use. The class limit is for us to use and also for us to build a table. Now we are ready. So and then to build them. So what you can do is click data and see if data analysis is here. If data analysis is not here, you go to file, option, add-ins, manage Excel add-in, go, and enable the first two. Or I think just the first one is fine. Check them and then say OK. In my case, I have data analysis available, so I don't have to do that. Or it has already been done. You only need to do it once. So you click on the data tab and then click data analysis. There will be a lot of packages or modules available, and the one that we want is histogram. And you click OK. The first things you need to tell Excel is your input range, which is all your data, and in my case I want to provide the header also. So I click label. That means the first one is not a data value but it's a label. And then under bin range would be the upper class limit, so I include the bin header label also. And then for the output option, I want Excel to just put the output in this worksheet, so I click a cell in the output range. The last thing I want to do is check output, so the histogram would show up, and I say OK. See, I would have, this is the frequency distribution for each class, and also this is the histogram. We need to do some adjustment. First of all, we'll copy this over. Well, actually, I just need to copy the frequency over in a new area, paste, and use the class limit that we have set up. So this is the class, and this is the frequency for this class. There's one data between 21 to 30, and there's a corresponding data values in this range, and that would be our frequency distribution. And you can, make it nicer by filling in the borders. And that's it. And maybe you want to change it, not instead of class limit, you want to say it as scores for class 1, something like that. And then for our histogram, what we can do is change the title. So maybe you would say histogram For class 1, frequency, instead of bin, it should be score, right? Now delete this. The last thing we want to do is click on the graph area, click on design, then under quick layout, I want to choose a layout that look like a histogram, because histogram's not supposed to have space between graph. And then you can also adjust the borders so the borders look nicer. Solid line, use black line, and that's it. So that would be a very nice histogram for your first population. You can go back to the original data, copy the second one, and repeat this whole thing to build a frequency distribution as well as a histogram for the second one.
And that's all we have for this class. Thank you so much, and we'll see you next time.